Here's our problem. So we're going to get started. Write a method that takes an array of integers and returns the two numbers that are closest together in value. Write a method that takes an array of integers and returns the two numbers that are closest together in value. Okay. So closest together in value, I'm taking that to mean that the difference, so the absolute difference, is the smallest. So I'm thinking closest being synonymous with smallest, and then together sort of translating to absolute difference between the two integers. So that's how I'm going to interpret that. I guess a question I would have here would be, is it possible to have an input that contains nothing? So that's one question I would do. Another one would probably be, is the input type guaranteed? Is the input type guaranteed? Another one I would likely think about here is, I suppose, how do I handle invalid data types in the array, assuming that it is an array? So those are just general input questions. Okay, and then our output here is just going to be a 2-element array containing the pair of values whose absolute difference is smallest. Okay, so that makes sense. Takes an array of integers. So I'm going to make some assumptions about input. I'm going to write some test cases here. So some input could be like 1, 2, 3, 4, 5. That satisfies the all integers, and the absolute difference, the smallest absolute difference here would be 1 and 2, or 2 and 3, 4 and 3, or 5 and 4. So the absolute difference for all of those, it could be any of those pairs. It would not be 5 and 1 because that absolute difference would be 4. So that's another question here. How should we handle a situation where there are multiple pairs of ints which have the same absolute difference? So that was basically, how should we handle a situation where the input array contains multiple pairs of integers which have the same absolute difference? So something like in the initial example here, 1 and 2, 2 and 3, and so on. I'm going to make the assumption here that we never have to worry about special number types. Big int. Okay, so those are just some things we don't have to worry about here. And I'm going to guard probably against invalid data types in the array, and also making sure that the first argument to our method or our function must be an array. So that's how I'm going to deal with that. But how to deal with this? Again, this is something that I would ask the interviewer, but I think it makes sense to probably take the first encountered. So in this case, if we encounter 1 and 2, and then 2 and 3, and then 3 and 4, say we're storing all of these because they all have some minimum absolute difference, then we would just take the first one that was encountered. So we would have to be thinking about how to store those in the correct order as they are encountered in our algorithm. So that's an assumption I'm making here. I'll just write that out. Assumption is that if there are multiple pairs with the same absolute difference, comma, return the first pair encountered. And that might be silly because that would be entirely dependent on the direction and our algorithm in general. So if I decided I wanted to traverse this input array from the right side, so starting at this element and working my way across the array, that would definitely have an impact. So I think this actually doesn't make a lot of sense as an assumption for the problem. So I think I'm going to change that to be, I'm going to make this assumption different. So we actually want to return the pair whose sum is the least, is the smallest. So in this case, say we had 1 and 2 and then 4 and 5. We'll just do that, just make it really clear. Based on these two, since they both have the same absolute difference, we would take this pair of 1, 2, because it sums to 3 as opposed to 9. Okay. I think that's a safe assumption to make, and I think it's in the spirit of the problem. Great, okay. And just to be clear here, returns the two numbers that are closest together in value. Yeah, okay. Just making sure that I didn't misread the problem. Smallest, and if dupes, and if there are multiple pairs, return the one with the minimum sum. Okay. So I've got a test case here. This one should return 1, 2. Let's grab another one here. If we have like something like 1, 1, 1, 1, 1, closest together in value. Okay, so this one would just be 1 and 1, and it would be, it doesn't matter which one. So that makes sense, I think. And then, so we have like -1 and 0 and 3, 4, 5. The minimum, or the smallest absolute difference would just be -1 to 0. So because that difference is just 1, so it would be -1, comma 0. I guess another question here, when we're formatting the, so I guess when, yeah, so put that here. Does the order of the two element array being returned matter? Question mark. It's the order of the elements. in the 2-element array being returned matter? So would we want it to be in ascending or descending order? Again, that's very easy to fix, but just something to think about. Maybe a situation where we have like a 3 that's a string instead of a number type, and then we can just leave that. We'd say this would probably just return some sort of error message or like null or something. Okay, so I know I want to add more test cases, but I also want to start thinking about making the rules really explicit here. So closest together in value is basically the absolute difference between two integers. And then we want the smallest, so closest together in value, absolute difference between two integers. I think that's still fair to say. And here, is it possible to have an input that contains nothing? I'm going to make the decision that yes, it is possible. And so this would just return error message. Is the input type guaranteed? I'm going to say no. Must validate type. How do I handle invalid data types in the array? Just error message or null. How do we handle a situation where, okay, so then this is an explicit rule. We can, or I guess it's more of an implicit rule. So we basically written it out here. If there are multiple pairs with the same absolute difference, return the pair whose sum is the smallest. Okay. And let's see, is there anything else? I'm going to make the decision that this does matter. Ascending order. So output, so result array, or the 2-element array returned must be sorted in ascending order. Okay. So those are some of our test case. Those are some of our explicit and implicit requirements. We should probably add maybe just like a test case like this, where it's just empty, and so this is just going to return error or null, and have one there. Perhaps it's just like the wrong data type. So this is again very much an error. There's always a situation where it's just there's nothing. So that kind of makes sense if there's just no argument being passed. And I'm trying to think if there's anything else I'm really missing here before I start thinking about what are the subproblems. So maybe something else will reveal itself. I'm going to keep moving. So in terms of like the subproblems here, it seems like we want to like validate input first of all. So this basically entails ensuring that the input type is the expected type and handling invalid inputs. And then another subproblem here is really the core algorithm here, which is we need to pass over the input array. And as we do that, I'm thinking there's a nested loop here, but we basically need to get every, is there anything about consecutiveness? Write a method that returns the two numbers that are closest together in value. Okay, I mean, it seems like this is a great opportunity to sort. So pass over the sorted input array. And so there, we don't need to worry about multiple passes with like some sort of nested loop. We just want to pass over the sorted input array using a window, a sliding window. And compare the absolute difference of the window elements with some result or minimum absolute difference value. So that seems like we would just be moving over it. So let's say for like this test case, it would just kind of look like this window here as we pass over. So this is already sorted at this point, but it's basically just gonna be like 1 and 2. So we are going to find the absolute difference here, and then compare that with some value, the minimum absolute difference value. And yeah, I suppose we also need, I guess we're sort of getting the algorithm at this point, but basically that's how it's going to work. So now if we move to the next iteration, then it'd be 2 and 3 and so forth. So that's what I mean by a sliding window. I'm just going to make that really clear here. So yeah, so then just compare this absolute diff with min absolute diff. And in the event that the absolute difference for that pair is less than the minimum absolute difference, then we want to reassign minimum absolute difference to that absolute difference and then store this pair somewhere. So that's going to be like probably like if it's smaller, store pair and update min absolute differences value. Okay. Looking at my timer, got about 8 minutes. So probably start on the algorithm here. And then at a certain point, if the pairs array, so this is going to look like an array of possible pairs like 1, 2, 2, 3, oops, 2, 3, and so on. So if the pairs array has a length of more than 1, then we would want to probably find the minimum sum for each of these, and then just grab the pair that has the minimum sum. So I'm not going to get into the specifics there. So just that's more algorithmic thinking, but yeah, let's get started on the algorithm. So guard for invalid input types, invalid array element types. So things like maybe like a string number looking thing, or just maybe something like that. Basically ensuring that every element in input array must be a number, and on top of that must be integer, which is more of a subtype of number. So we've got that. Okay, and so I should probably add that test case. So let's do something like this, 2.1. And yeah, okay, so I'm just going to use strict. So then this is just another error. I think I'm going to make the decision of just returning null for those invalid input types. Okay, so that makes sense. It must be a number, and that number must be an integer. Okay, cool. So that makes sense. So this would mean that for must be integer, if we are to, I guess we would just use the remainder operator here to check for remainder, check for ints. Okay. And let's see. I think that makes sense as far as what we need to guard for. So the next step here was we want to pass over the sorted array. So first of all, sort input array. And again, it doesn't actually matter the direction it's sorted in, ascending or descending. For now, I'm just going to do ascending. Store in a variable. For result, or I guess that actually doesn't matter because we'll be mutating, which we usually don't want to mutate something. So we're going to create a copy of input array with slice, and then sort slice of input array, and store this in a variable. So once we have that sorted, basically just need to compare the absolute difference of the window elements. So we want to traverse sorted slice with index, and this is going to be starting at index 0 and going up to, but not including the length, sorted slice length minus 1, so that it doesn't go beyond the end of the array. And as we do that, we want to compare the absolute difference. So we need to take two values from there. So let's say it's like math absolute, and let's say it's like 1 and 2. That's just going to be 1, which makes sense. What if it's like 8? Maybe I have that wrong. Oh, okay. So we need to take those values. So it would be like 1 minus 8, or 1 minus 8, right? And that'd be 7. 1 minus 2, that'd be 1. Okay, yeah, I just was using that method incorrectly. Okay, cool. So I guess using math absolute value, we need to subtract like window first and window last. And then just take that value. And so if this value is less than the min absolute difference value, then we want to, I need to let my dog in real quick. If the value is less than the minimum absolute difference, then we want to push window into result array and update min absolute difference value to the calculated absolute difference of Windows values. Okay. Of subtracting Windows values. Okay. Great. So, and then else, it would simply continue to next iteration. Okay. That makes sense. So then when we get towards the end, we basically just want to check if result array's length greater than 1. If it is, then we know we need to find the, so I guess check if that, if longer, I guess if greater than 1, then we need to, or I guess if it's not greater than 1, so if it's if equal to 1, we can just return first element in return sorted first element in result array. Else we need to find those sums. So find sums, and I'm saying I'm just at 25 minutes, so I'm going to add some more time. Let's just say add 10 minutes. So find sums for all windows, and from there, sort these in ascending order. And then from there, return the first element in result. And we're actually going to be storing this like, let's say we have like a couple like this. It's going to look like we're going to transform it. So the third element in the array is going to be the sum. So that's going to be 3, and then that would be 5. So I'm just going to like write that out. So like A, B, and then sum of A, B. Okay. So that's like what that would look like. Yeah, okay. So that I think that makes sense in my mind how that would work. So we should probably run through an example first. So I'm going to grab our test cases, move down here, and find min abs diff. Okay, cool. So if we're looking at like this, let's look at this test case. So this is caught by the guard clause, not an integer. This is fine. This is fine. This is fine. These are all caught by the guard clauses. So maybe I should move that one down. Yeah, okay. And yeah. I don't have to worry about infinity, so that's not too bad. So okay, so let's just look at like this one. So we pass the guard clause, we create a copy with slice and sort that slice. So then it would look like -1, 0, 3, 4, 5. So it's really the same order. And then we just want to traverse it from index 0 to the length -1, non-inclusive. And for each window, we find the absolute difference. So that's just taking the two values and subtracting one from the other and then finding the absolute value. And so that for this case would look like, I'll just go way over here. That's going to look like for the first two, it's just, so we're looking at this test case, the third one here, line 67. So it's going to be 1. It's like 1 and then 0 and 3, so 3, and then 4, 1 again, and 1 again. So that would be 3 pairs that all go there. And so we would have 3 pairs. So we would have the -1 and 0, 3 and the 4, and the 4 and the 5. And we should probably, we'll write that here, declare result array and declare initial value, or declare min abs diff value. This is just going to be infinity starting out. So it would have seen that we would be comparing these values with the current value of minimum absolute difference. And if it's less than, we want to reassign it and push that window into, and we'll call it a pair. So pair first. Boy, that's annoying. Pair first. Okay, cool. Am I calling it window anywhere else? Yeah. All pairs. Okay. Makes sense in my head. Yeah, this feels good. So we would have that result array of pairs, those pairs being 2-element subarrays. And from there, we would then transform the result array into an array of 3-element subarrays. And then from there, we would want to sort them based on the last element. So this 3 or 5, whatever the sum is. They want to take the minimum, so sorting in ascending order makes sense. Did we make note of that? Ascending order? Yeah. Okay. I think we can get into it here. I'm going to bring these back together. We've got 4 minutes, 4.5 minutes. Find minimum absolute difference, input. Okay, so if we consult our algorithm here, we want to guard for invalid input types. So if it's not an array, we just simply want to return null. If the input array elements are not integers, or I guess are not numbers, so every single one must be a number. So every element must be a number. Every element must be a number. So if every element, so if every element, or if some, I'm actually going to use some here. So if some element is not a number, we want to return invalid input, invalid elements. Okay, and I'm actually going to add another test case here. Let's place it right there. And we'll just do like not a number or something. And this would be error. Okay, cool. So that would work. We might as well throw that in there as well. Infinity. So I just want to, I'm going to test where we're at currently. And so it's going to catch this one, catch this one, catch this one. Well, actually, we're not catching this one yet, so I'm going to comment that out. But for all the others, it should catch. So if input length is 0, so if it's an empty array, I want to return empty array. Okay, so that works for this one, this one, this one, this one, and this one. So if we exit, and okay, I got to change the folder. Okay, so it's 109. So change directory, live 109, node 4. Yes, okay. So we've got, initially we've got an undefined here. Yeah, okay, so we haven't filtered for the special numbers yet. So every element, some of the elements are there. Okay, so we need another one here. If the input, if some element in the input is not a number or infinity or negative infinity, then we want to return invalid elements. Okay. And let's think, what's another one I could worry about here? So now we should not be seeing that initial undefined. Great. And so all of our error messages look to be working. So yeah, we just need to focus on these test cases now. I'm going to comment these out. And it looks like we're still going to run out of time here. Okay, so let's see. We want to deal with this one. So I'm going to write a little helper function here. So const all ints. And this would be an lm, so a number. And basically just check if input dot every element is all ints. If they're all integers, if they're not all integers, I'll just do is int. If not every single one of them is an integer, so if we'll just say not integer, so if some of the elements in the input are not ints, then we would want to return invalid elements. Okay. So const not int, and we got to place that up here. So do number remainder 1 is equal to 0. So if it's not equal to 0, and it's not an integer. So let's, I'm just going to place that in my repl here. Not int, so if we do not int 3, that is an integer. Ooh. How do I check if it's... How do I check if it is an integer? If it's divisible by... That's a good question. Okay, so I guess we wouldn't have passed this interview perhaps, because I think we're at about 40 minutes. Let's see. So I guess I'm just going to try to focus on solving this problem as best I can and just kind of working through it at the appropriate, I guess, clip and pace. So how do we check if something is not an integer? So it's divisible, so divided by something. So if it's like 3.1. So I guess we could take like, we could round it, right? So it'd be like math round 3.1. And if it was like, if it is a number, it's equal to 3, that's true. Okay, that's how you do it. Okay, so math dot round number must equal number. Okay, so we'll just grab this and set in there. Wait, what's the not equal? Oh, it's already been declared. Okay, so I'm just going to make. I think it works. Okay. So if sum is if it's not equal to that, so it's not an integer, this would return false. Okay, so let's check that here. It's the third test case. No, it's the fourth test case. Okay. Undefined and invalid elements. Okay, so it is catching that number. Great. So that means we're passing that one. Okay, cool. So now we can just get back to our algorithm. We've dealt with the invalid inputs. So we want to create a slice. So I'm just going to do const copy input slice from 0 forward. And let's just return copy array, or copy input, and check that. So we're seeing what we wanted. And we also wanted to sort it. So we change that, sorted input. Okay, so they're sorted now. We might as well, I'll just make sure that, actually, no, that's fine. We don't have to do too much. And it's sorted in ascending order, which is what we wanted. All right. Okay, we've got it sorted in a variable. Now we need to declare a result array. Pairs. Empty array. And let min absolute difference equal to infinity. Okay, so now we want to start our iteration. So get a for loop going. This will be index. This will be sorted input length. And then we're just going to get rid of that. And we want to make it non-inclusive. So let's just log the index. Let's actually log sorted input index, and it'd be slice from index to index plus 1. Okay, and then we're just going to look at one of these cases. So we got 1. Okay, so it actually needs to be plus 2 because of slice being not including, going up 2 but not including that element. So now we've got 4 subarrays, which is what we want. So that looks good. It's going to take that. So this is the pair, right? Take the pair, and we need to get the minimum absolute difference. So if we'll actually grab, we'll just say let absolute difference equal to pair or math. Let's do, we don't need to get fancy here. Absolute value of pair at index 0 minus pair index 1. And let's just log that. Okay, so now we're seeing 1, 1, 1, 1, which makes sense. Let's check it for another test case. Let's look at this one. It would be 1, 3, 1, 1, which is what we were expecting. Okay, so this is working. So now our algorithm says that we need to check to see if it is less than the minimum absolute difference. So if min absolute difference is greater than, let's write it the correct way, if absolute difference is less than the minimum absolute difference, then we want to push pair into the result array. So result or pairs push pair, and we also want to reassign min absolute difference to the absolute difference of that pair. Okay, cool. So let's take a look at what our pairs look like. Okay, so we've got 1, 2, and then minus 1 and 0. Were we expecting that? We were not expecting that. I was expecting to see the 2, 3, the 3, 4, and the 4, 5 as well in our result. So I guess if it's less than or equal, yeah, okay, that's the problem. Okay, cool. So the problem was that we were trying to compare some value. And so say it was like the minimum absolute difference for one of these, for all of them in the first test case here is 1. And it was checking 1 less than 1. And that's, that's false. So we didn't account for when they are equal. Great. Okay, so we got that working. Otherwise, we should continue the next one. So this is looking good. So now we just need to check if result array, if pairs length is equal to 1, then we can simply return pairs at index 0. So for this one, it should just return. Otherwise, we should get undefined. What's the problem here? So pairs length. Okay, yeah. So for neither of those is it that test case. So maybe we will add a test case here. One, or how about just like 1 1? So then this should be 1 1. Okay, so here we go. So we're seeing that. Great. And so if it passes this, then it means we have multiple pairs, and so we need to perform that transformation. So we've got the pairs array. So it's going to return pairs map pair. Okay, and we just want to return pair concatenated with pair at index 0 plus pair at index 1. So if we take a look, great, okay, so now we see there's 3 element arrays. And so with this, we want to sort by the last element. So it's going to be something A and something B. Okay. I'm going to sort by those, and there we go. Okay, so then that is going to be sorting, and it just needs to be A minus B. So let's take a look. So we went from 3579 to 3579. And that makes sense because they were, okay, so that looks right. And -1, yeah, okay, so that's cool. So now that it's sorted in this manner, we simply want to return 0. So the first subarray, slice from 0 up to 2. Oh, 0 up to 1. And that's wrong. What's up? Maybe 0 up to. Okay. I guess it just bugged or something, or it didn't update. So there's our solution. 1, 2. Let's just make sure they're all correct. So 1, 2, 1, 1, -1, 0. So we'll just log it all again. 1, 2, 1, 1, -1, 0, 1, 1. Error. Yeah. So that was a little rocky. I'm still getting better at this stuff, but I hope somebody finds this helpful. I think there's a lot to take from this for me personally, where I just kind of didn't spend enough time with inputs and outputs, I think. And I really spent a lot of time in this guard clause getting kind of turned around with some versus like every, and also just like the question of how do I figure out if this is an integer or not, and I just having a bit of a brain fart here. So yeah, thanks for taking with me if you've watched this far. And yeah, I hope that was helpful. I hope there's no major problems with my solution. Great.